Hey guys, welcome back everybody. Today we're going to discuss about how to configure the OSPF routing protocol on a Cisco Packet Tracer. OSPF is also known as a linked state routing protocol. It's one of the best protocol for the big enterprise network and the service provider network as well, right? So even you can also use this protocol in the data center network as well. So in this topology, you can see that I have a router number 1, router number 2, and router number 3, and they all are participating into the area number 100. I'm not using the area 0 backbone area, just to show you that without backbone we can still have a single area configuration, right? So right now this lab is all about the single area. In the next video we'll talk about the multi-area configuration. So it's the same topology, you can see that we have discussed in the EHRP protocol as well. So we have a 12.0 subnet between the router number 1 and router number 2, and between the router 2 and router 3 we have a 23.0 subnet, right? We have IP address for this interface. Gig 0/1 is 12.1, gig 0/ is 12.2, gig 0/1 of the R2 is a 23.2, and gig 0/0 on a gig 0/0 on R3 is a 23.3, and gig 0/1 on R3 on the 2.254. This 2.254 will become the default gateway for the R3 and R4, sorry, PC3 and PC4 as well. This is a Bangalore location. Same thing, if you see over here, this is the Delhi. In the Delhi, we have a PC1, which is the IP address 101, and the PC number 2, which is the IP address 102. And again, for this guy, the default gateway will be 1.254. So the step number 1, what we can do that, let's configure the IP addressing. So I'll go to the laptop number 1, and I'll start configuration from here, config, and I'll go to this guy 101/24, and the 1.254 will be default gateway. Same thing for the PC number 2 as well. And here we go, 1.2/24 and the 1.254. Same thing I need to configure on the PC number 3 as well. This would be the 2.3, right? And /24, and this will be go with the 2.254. That's good. And same way on the PC number 4 as well. 2.4/24 and the 2.254. Right? So the IP address is configured now, and now we need to go on the router number 1. On the router number 1, we need to configure the IP configuration. Also the no enable config terminal hostname router number 1, interface 0/0, sorry, it's a gig 0/0. IP address would be 1.254/24, right? No shutdown. And then we have a interface 0/1, which is the 12.1 IP address, right? 12.1/24, no shutdown. Right, my both interface is up. If you want to verify it, you can use the do command in the global configuration mode, show IP interface brief. All good. So we have IP configured. Same thing, I need to go on the router number 2 and configure the IP address, enable hostname R2, interface gig 0/0. This is the interface I'm talking about right now, 12.2, and /24, no shutdown. And then we have another interface is a gig 0/1, interface 0/1, right? IP address will be 23.2. All good. And now finally we have router 3. On router 3, enable config terminal hostname 3 and interface 0/0, which is this interface right now, 23.3, and IP address will be 23.3/24. Then we have our interface 0/1, which is the LAN interface, the 2.254. All good. Now what we can do that, we need to, all my IPs working good, I need to configure the OSPF routing protocol. So let's start with the router number 1, and on the router number 1 we'll go and say that router, put the question mark, I have a bunch of options. I would like to go with the OSPF routing protocol right now. I said the OSPF, and you need to give the 16-bit of the process ID number, right? We'll talk about this process ID in the next video, right? What is the use of process ID? So just let me tell you that process ID is a, it's a uniquely present on the router side, and for every process ID, what happens, you will have a separate LSDB table, the database table, and for every process ID, you will have a separate route ID and the separate SPF algorithm as well. So on a single router, on a single router, you can run the multiple process ID, right? Let's say example, you have a service provider. There's a router over there. That's the service provider router. And this service provider router has a connectivity with the multiple customer 1, customer 2, and customer 3. In that case, on this service provider router, you can run the 3 process ID. One process ID for the customer number 1, another process ID for the customer number 2, and another process ID for the customer number 3. So if you have this kind of scenario, you can run the multiple process ID as well. But right now, it's running in the single company network. That's why I'm going to configure the one process ID. And I'm going to configure the router ID will be 101, right? Network will be 192.162.0, right? Now, most of the people has a confusion about this part. Sorry, right? There was some misunderstanding what's happened. Okay, let's continue. So I was talking about the EHGRP routing protocol do also use the wildcard mask. Even the OSPF routing protocol do also use the wildcard mask. But in EHGRP protocol, what happens if you have a classful network? In that case, you don't require to use the wildcard mask. If you have a class list, it is recommendation to use it. Now, if you see that in the OSPF routing protocol, what we can do is a network 12.0, and I'll put the wildcard mask, match it, and the fourth octet will be ignored. And then finally, I'll call this guy the area number 100. So you can define the area in the two format. Either you can define in the decimal format, or either you can define in the dotted decimal format. Right now, I'm defining the decimal format. And then same way, we have another network is 1.0, wildcard mask 255, and area number 100. That's all. Now, same thing, I need to go on the router number 2. Router OSPF number 1, router ID will be 2.2.2.2. Also, the network will be 12.0, area 0, area number 100, I'm so sorry. And then we have our network 23.0 and area number 100. Perfectly fine. OSPF is the pretty slow routing protocol, right? It takes the 40 seconds, which is the DR election timer, also known as the wait time. So you need to wait for the 40 seconds to form the neighborship up. And then we have R3 as well. On R3, we have router OSPF number 1, router ID will be 3.3.3. Network will be, I have a 2 network. What we can do that, let's do something magic over here. I'm gonna use the single line of configuration to advertise both the network. What I can do that, if you see that we have a 192.168, and same way we have a 192.168, right? So both the two octets are matching right now. The third octets, we have a variant 23 over here, and we have a 2 over here. So what we can do that, I'll just gonna match the 2 octet, right? Match it, and ignore the third and fourth octet, and I'll call the area number 100. So in a single shot, what happened, I'm gonna advertise both the link. Now let's go back to the router number 2 and check my neighborship is up right now with router number 1, and it's coming with the router number 2 as well. So if you see the show IP of neighbor, I have a router 2 is forming the neighborship with the router number 1, right? And router 2 also forming the neighborship with the router number 3 as well, and both are in the full state, right? So router number 1 is behave like a BDR, and router number 3 is also behave like a BDR right now. So my this two interface 0/0 and 0/1 both are in the DR state. Okay, I don't think so this command is going to work on the Cisco Packet Tracer. Maybe this command we can check it. So you can see that the gig 0/0 is a DR right now, the 2.2.2, the IP address for the 12.2, which is this guy. And same way we have another interface gig 0/1, and they are also a DR for this particular broadcast domain, right? Now that's good. Let's go back to the router number 1, and let's quickly verify the routing table. So you have a single area. In the single area, you only have a one type of route, which is called as a O route, also known as a intra route. So IP route, if you see that OSPF, I can see I have a O route. So I have a route for the 2.0 subnet and the 23.0 subnet as well. So this is the AD value, and this is the metric for the OSPF protocol. So metric depend on the bandwidth. Now, what we can do that, you can also check the show IP for database. So you will see the database, we have a router LSA and we have a network LSA. So of course, 3 routers, we have router 1, router 2, router 3. So you will have a 3 router LSA. And right now I have a 2 network 12.0. I have one DR over here. I have another DR over here. So that's why I have a 2 network LSA. So the 12.2 is going to generate the 1 network LSA, and 23.2 is going to generate the another network LSA. That's good. Now it's time to check the connectivity. What we can do that, I'll first ping my default gateway. I'll first ping the same subnet, right? 1.2. if the ping is going to work, it means that my LAN communication is good right now. Now let's ping to the default gateway, which is the 254. Awesome. My connectivity I have till the default gateway. Now I'm going to send the packet to the 2.3, which is the from the Delhi to the Bangalore. All good? And I say the same ping for the 2.4 as well. So sorry. All good. So my ping is working fine right now. All the configuration is good. I'll quickly recap you what we have done. So it's just a single area configuration we did it, and we are running with the OSPF area number 100. We are not configured the area 0, which is called the backbone area. In the next video, we'll talk about how to configure the OSPF multi-area configuration as well. See you in the next video. Thank you so much, guys.